Physics Part 439. In order that interference between phone calls does not occur near the boundary between two cells where the signals from two base stations overlap, the band of carrier waves frequencies allocated to neighboring base stations is different. This is illustrated on the figure by the number of each cell. When a mobile phone handset is switched on, it transmits short signals at regular intervals in order to identify itself. This signal is detected by one or more base stations. The base stations transfer the signal to the cellular exchange, where a computer selects the base station with strongest signal and also allocates a carrier wave frequency for communication between the base station and the mobile phone. During the time the handset is switched on or is actually in use, the signal strength is monitored at the cellular exchange. If the caller moves from one cell to another, then the relative strength of the signal from base station changes. The call from the handset is rerouted through the base station that provides the strongest signal. The mobile phone handset. A simplified block diagram of the mobile phone handset is shown in the figure. Basically, it consists of a radio transmitter and receiver. The caller speaks into the microphones. The microphone produces an analog voltage of the sound wave that is amplified using the audio frequency AF amplifier. The analog voltage is converted into the digital signal using analog to digital converter ADC. The parallel to series converter takes the whole of each digital number and emits as a series of bits. We've got a figure over here. At the top of the mobile phone handset, we've got an aerial, we've got a switch, we've got turning circuit, we've got RF amplifier, we've got demodulator, we've got serial to parallel converter, we've got digital to analog converter, DIC, we've got AF amplifier, we got loudspeaker, we've got amplifier, we've got modulator, we've got oscillator, we've got parallel to serial converter, we've got analog to digital converter, and we've got ADC, we've got AF amplifier, and we've got microphone. So this is in fact the diagram of the mobile phone handset. The frequency of the oscillator is allocated by the computer at the cellular exchange. The carrier wave frequency modulated by the series of bits from the parallel to series converter. Finally, the modulated carrier wave is amplified and switched to the aerial where it is transmitted to the radio wave. Any signal received at the aerial is switched to a turning circuit. This circuit selects only carrier wave frequency that has been allocated to the handset by the computer at the cellular exchange. The selected signal is amplified by the radio frequency RF amplifier. It is demodulated so that the information signal is in digital form. The series to parallel converter enables each sampled digital voltage to be separated, I beg your pardon, digital voltage to be separated, and these digital numbers are then converted into analog waveform in the digital to analog converter DIC. Finally, the analog signal is amplified before the sound is produced in the loudspeaker. We've got the section summary for you. In a mobile phone network, a region is divided into a number of cells, each with a base station. The mobile phone is connected to the public switched telephone network PSTN through a base station and a cellular exchange. A computer at cellular exchange selects the carrier wave frequency for each handset and also the base station that is to serve the handset. I got a section question for you. Outline the role of the computer at the cellular exchange in a mobile phone network. Another question for the section. Draw a labeled block diagram of a mobile phone handset. 2B. Outline the function of each block on the diagram. That's all for physics. My tutorials on physics, quite long ones. We have a total number of videos, as many as 439 videos on physics. Certainly a very, very important subject, physics. And we have recorded 439 videos. Most of the videos are of 5 minutes, but there are few videos even longer than 5 minutes, and then there are others shorter than 5 minutes. That's all for physics with video number 439. Bye bye, take care, talk to you later with another series of YouTube video. Bye.